So we just talked about authentication, and there's a bunch of authentication labs here, and they're nice. Let's take a look at a couple of them. Here's the authentication system. All right, so let me open this thing up here. Here's simple one, username enumeration. This demonstrates the simplest flaw that we just talked about. So if you go here into the lab, I've got a list of candidate usernames and candidate passwords, which are changing all the time, which is pretty cool. So if you go here and you try to log in with my account, then if I put in a username of AAA and a password of BBB, it tells me invalid username, which is just what they say they shouldn't do. So I can try the usernames without knowing the password and then try the password separately. So that's what we're going to do. So if I go into burp and find the last request that did that, that would probably be this one, the post login. And I can check to make sure that's the right one by looking at the response and rendering it. And that's it, invalid username. So this is the, now, so what you do is we're going to use the intruder. It has a technique just for this called intruder. And so the intruder lets you try a list of options to break into something. So you have the request here, and it guesses what you might want to change and indicates it with these section marks. I don't want to change both the username and the password at once. I want to clear the section marks and then put section marks just around the username. So I select that and put them. So now I'm only going to change one variable, and I'm always going to use the same password. Now, the sniper attack is what I'm doing, where it's just going to change the contents of that one field. So I'm going to have a simple list here. So I can take all my possible usernames, which are here, and there's 100 of them, I think. So I get them, copy them, and paste them in here. And now I'm ready to go. Now I start the attack. Now, burp will run it slower than it has to be just to punish you for using the free version, but it's still running pretty fast. And so, see if I can get this to show me. Oh, here we go. There they are. So here it is trying all these different payloads, and here's the status and the length. And what you're going to do is look for one that is different, a different status or a different length. That's not a very perfect test, but in practice, this is usually good enough. So it's about halfway through them already. So I can search through it for this one, or I can just sort by length. And I haven't found it yet, because one of them should be different. But you see, it's still going pretty fast. They've made this faster than it used to be. It used to be really painfully slow. Good, you see, there you are. There's one that's different. So apparently Analyzer is the right username. Good, so I can stop this. Guess I can just close it. All right, a discard. So it's Analyzer.
What is that length field?
Link?
Is it length?
Length.
Yeah. What is that field?
It's just the number of bytes in the reply from the server. And yep, that's all it is. Yep. So it's not perfect. In principle, you can have two responses with the same length and it wouldn't tell them apart. But in practice, it's good enough. Doing something like a hash would probably be more perfect, but this is good enough and it's faster. So now that I've done that, I can go back to here, and I know it's going to be Analyzer. So let's put that in. So let's clear all these. Clear, I say. All right. And now let's put in Analyzer. All right, and now let's guess the passwords. So I put a mark there, and now go to payloads, and now I gotta clear this, and let's put in the possible passwords, which are here. All right. So paste.
Where do you get the list of username and password?
They come from burp, and they are in fact, they look. Yeah, they come with the exercise, and they are in fact like the top 100. I've seen them before, so you could use them. Usually, in a real case, you'd have to have much longer lists, like the top 100,000 or something. But they are pretty much the common ones. All right, and so now I'll start this attack and guess the password separately, and it's just the same. I just want to see the one that comes out different, and somehow I'm not able to grab this thing. It's running, but I can't see the answer because something's wrong with the GUI. Let's see if I can somehow get this thing to, there we go. There we are. Okay. Oh, wait, it looks like I'm getting, there's the difference, 302. That's probably it. See, even though I have different length, and pointed, by the way, this can happen. After this, I'm logged in. So now I'm getting a different answer. But the 302 redirect is usually the one that got in, because then it takes you to some other page, like the username. So if the 302 one, that's probably it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. If I go to the response here, that's found, and now it redirects me somewhere. So I think I know the password. So it was analyzer and 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So I should be able to log in with that. So if I go here, this one here, analyzer. They're not listening to me. And all the numbers. And I'm in. So I win. All right. So that's the simplest basic attack, relying on it leaking information so you can guess the things one at a time. All right. And there are various other ways to do it wrong. Like here's a simple bypass of two-factor authentication. This is insecure direct object access, and you don't even need burp. You know Wiener Peter. The victim is Carlos Montoya, because they're using two-factor authentication. So, oops. I'm going to open it in this. That'll do. I remember it. Wiener Peter and Carlos Montoya. Okay. So if I log in with the account I know, Wiener and Peter, Wiener, I think, and Peter. Okay, it's going to be two-factor. So I log in here, Wiener Peter. Now it wants the other factor, and here's the email where I can see my other factor. So my other factor is 0493. So that's my code here, 0493. Now notice the URL. This is login to, and after I put in the second factor, now I'm at my account. So if I just copy this into the clipboard, and now I try to break into the other guy's account, I go back here and do Carlos Montoya. Okay, and I log in, and it asks me for the second factor, but I can't get it because I don't have access to his email, so I just ignore this and go to that other location, my account. And now I'm in. This is called insecure direct object access. They didn't actually limit you to get to that page. They just put a block that they expect you to go through to get there, but you can jump right past it and get there. This is extremely common on servers. They find it too difficult to verify your identity everywhere, so they just hope you won't find the page unless you've logged in. But
Is this because of persistent cookie or something else?
no, this is just, this page is probably open to anybody who's made, once you've made it through the first stage, it knows who you are. Yes, because the first stage must load a cookie, you're right.
Yeah.
So it knows that's the first stage must load the cookie, and the next stage just blocks your access to this page. This is very common. They make it look like you can't see the data without having the second factor, but they didn't actually require the second factor to get you in. You're right, what they should have done is require the second factor before they give you the cookie. But that would mean they need two different kinds of cookies. They'd have to have one that means you've only passed the first stage, and then they didn't bother to write all that. This is it's a little more work, and so it's very commonly done. Yeah, this is the broken access control. They used to call it insecure direct object access. This is very similar. They didn't really correctly do all the tests that were needed for the login stage. And that's what I was saying, thinking, there's just 2 or 3 steps. How hard could that be? Well, it's pretty hard. And it's very likely that your average developer writes code, and then they test the code for functionality. They say, does it work? When legitimate users try it, it works. When I put in the wrong number, it fails. There, I'm done. They don't try more difficult tests. And that's why you need pen testers. They don't actually try, what if I mix the data from one user with the data from another user? What if I cheat using a proxy and skip over a step? They don't try any of that weird stuff. They just try the normal use case, and when it works, they say, I'm done. All right. So anyway, that's one there, and there's a lot more of these, but I think that's enough to just see how it works. So I'm going to stop this recording.